In this video, we will learn how to solve linear and absolute value equations. So to begin with, we need to understand a few basic definitions. First is the word equation. So equation is a statement about the equality of two expressions. So something stating that two different things or values are equal. And then when we say solve an equation, solve means to find the values of the variable that will satisfy the equation, or in other words, that will make the equation true. And then we have what's called the solutions or roots of the equation, which are the values that we find that satisfy the equation. And then we have what's called an equivalent equation, which are equations that have exactly the same solutions. So make sure you understand these basic definitions because we will use these different words as we progress in the lesson. So with equations, we have different properties of equality. First, we have the addition and subtraction property, which says that we can add or subtract the same expression to both sides of an equation to produce an equivalent equation. So for example, if we had x minus 3 equals 7, what we can do to solve for x is we can add 3 to both sides, and when you do that, the 3 and negative 3 will cancel, and now we have 7 plus 3, which is 10 on the right side. So by adding the 3 to both sides of the equation, we now have solved the equation, and our solution or root would be x equals 10. So that illustrates the addition property. Here we have x plus 3 equals 7. And to solve this equation, you would have to do the inverse of adding 3, which is subtract 3. So we can use our subtraction property by subtracting 3 from both sides of the equation. And when doing that, 3 minus 3 would cancel out, and you're left with x on the left side, and then 7 minus 3, which is 4, on the right side. So the solution would be x equals 4. And then next we have the multiplication and division property. And this is basically the same thing as the addition and subtraction property. And this property says that we can multiply or divide the same non-zero number on both sides of an equation to produce an equivalent equation. So for example, if we had 3 times x equals 15, to solve for x, we do the inverse of multiplication, which is division. So we divide both sides by 3. 3 divided by 3 would cancel. You're left with x on the left side. 15 divided by 3 gives you 5 on the right side. So your solution, or root, would be x equals 5. And then over here we have x divided by 3 equals 5. And to solve for x, we can do the inverse of division, which is multiplication. So we can multiply both sides by 3. X over 3 times 3 would give you x, and then 5 times 3 would give you 15. So your solution would be x equals 15. So we have shown or illustrated the division and multiplication property. And again, that property says that we can divide the same number on both sides of the equation or multiply the same numbers on both sides of the equation. And this is going to be necessary as we solve different equations. So the first type of equation that we're going to solve is going to be linear equations. And a linear equation, by definition, is a first-degree equation that can be written in the form ax plus b equals 0, where a is not equal to 0, and a and b are real numbers. All right, so the key here is that we have whatever variable we're working with, we have that raised only to the first power. So if you see like x squared or x cubed, okay, that would not be linear. Now we have an example of solving, and this jumps pretty quick into a lot more difficult type of problem. So we went from a one-step equation to now we have a lot of different things thrown in at one time. So we're going to walk you through kind of the thought process and the steps that you need to solve this equation. All right, so when you have an equation, you always want to simplify the left and the right side first. So for example, this left side, we can distribute the 3 to both terms in the parentheses. And on the right side, we can distribute -6 to both terms. So that would give us 24 plus 24n. We see that typed up here. And then on the right side, we would have -6 times n, and then plus 24. All right, so that's the first thing you want to do, is simplify the left and the right side. And if you look here on the left side, we actually can simplify further. We have -10n plus 24n. That would give you a positive 14n. And we see that typed up right here. All right, so nothing else can simplify. And now, if we need to bring the n's or the variable to the same side. So here we see that we have 14n on the left and then -6n on the right. So we need to either bring 14n to the right side with a -6n or bring -6n to the left side. So we can do either, but we'll probably want to bring the -6n to the left side to keep everything positive. And to move that over, we do the opposite of what we see. So we see a -6n or -6n. So the opposite of negative or minus would be add. So we're going to add 6n to both sides. When you do that on the right side, 6n minus 6n would cancel out. On the left side, we would have 14n plus 6n, which gives you 20n. So we have 20n plus 24 equals 24. All right, so we've simplified. Now we have brought the variables to the same side of the equation. And then to finish off, you're going to work in reverse order of operations. So remember, order of operations, we do parentheses, exponents, multiply, divide, add, subtract. Now in solving equations, we work in reverse. Here we see 20 times n, that's multiplication, and then we see the 24 being added, that's addition. So working in reverse, we take care of the 24 first by subtracting. So we do the inverse of whatever we see. So 24 minus 24 cancels. We're left with 20n equals 0. So we've done the addition. Now to finish off, we take care of the multiplication. So to get rid of the 20 with the n, we do the inverse of multiplication, which is division. And we divide both sides by 20. So now we have n on the left equals 0 over 20 would give you 0. So after all that, our final answer is n equals 0. And we see that typed up right here. All right, so that process you can use for any type of linear equation. So again, to recap, what we are doing is we're simplifying the left and the right side. And then from there, we bring everything, all the variables, to one side of the equation. And then you work in reverse order of operations to solve. Now, what if we have fractions? Well, if you have fractions, we could go through the same process, that we just showed you. Make sure we simplify left and right side. Make sure we bring the variables to the same side of the equation, and then work in reverse order of operations. But a simpler way to begin with is we can just get rid of the fractions right at the beginning. And then from there, it's going to make life a lot easier. All right, so here what we see is 3/4 x minus 1/2 equals 1/4 x minus 3 over 2. So the technique we can use to clear fractions right away is we can find the least common denominator. So we look at each of the fractions. We have 4, 2, 4, and 2, 4 denominators, and the least common denominator would be 4. So what we do is we take both sides of the equation and multiply everything by 4. We see that typed up right here. All right, so make sure that we distribute 4 times 3/4. When you do that, the 4's cancel, you're left with 3. And then 4 times -1/2. So 1/2 of 4 is 2. So 4 times 1/2 is 2. So we have 3x, don't forget the x. 3x minus 2 on the left side. And the right side, we distribute the 4 to both terms. 4 times 1/4 gives you 1. So we have 1x. Then 4 times -3 over 2. 4 times 3 over 2. That gives you 12 over 2, which is 6. So we have x and then minus 6. So that one step of multiplying by the least common denominator makes the equation much simpler. And then from here, we can simplify the left or right side as needed. And in this case, there's nothing to simplify. So then we can bring the variables to the same side of the equation. So we can bring this 1x to the left side by subtracting it over. When we do that, the x's cancel on the right side. You're left with 3x minus 2x, or sorry, minus 1x, which is 2x on the left side, minus the 2 equals negative 6. So now the variables are on the same side. Then from here, we can work in reverse order of operations. All right, so working in reverse, we have a 2 being multiplied with the x, and then we have a 2 being subtracted. So when you work in reverse, you take care of subtraction first. We do that by doing the inverse of subtraction, which is addition. So we add 2 to both sides. We have 2x equals negative 4. So subtraction is done. Next we have multiplication to take care of. So to get rid of the multiplication of the 2, we do the inverse of multiply, which is divide. So divide both sides by 2. That leaves you with x on the left side. And then negative 4 divided by 2 is negative 2 on the right. So your final answer is x equals negative 2. Now when you're solving equations, you might run into some different scenarios. So we have 3 different types of equations that you might come across. The first is what we call a contradiction. So that would be something like this, where you have an equation that has no solution. And actually we'll get some examples in a moment. So a contradiction is an equation with no solution. A conditional equation would be a regular equation. So it's typically only 1 or 2 solutions, but it's going to be some finite number of answers. All right, so it's an equation that is true for some values, but not all values. So there's a finite number of answers. And then you have an identity. And this is an equation with infinite answers. So this would be an equation that is true for all values of the variable. All right, so contradiction has no solution. Conditional equations have a finite number of solutions. And an identity will have an infinite number of equations. So if you want a way to remember, I for identity matches with I for infinite. All right, and then contradiction kind of makes sense. It's going to be something that doesn't make sense. It would have no solution. And then the last one, conditional, would be the finite number of solutions. So what does this look like when you're actually solving? So here we have x plus 3 equals x minus 1. And if you're trying to solve, you need to bring the variables to the same side. So we have to subtract x from both sides. And when you do that, it's going to cancel on both the left and the right side. So what you're left with is 3 equals negative 1. So the variables are gone. This is not a true statement, it's a contradiction. So because of that, it's going to have no solution. And again, we would call that a contradiction. Here's another example. We have 3x minus 5 equals x plus 13. To solve this equation, you want to bring the variables to the same side. So let's bring x to the left side by subtracting x. So if we subtract x from both sides, x's on the right would cancel. You're left with 2x minus 5 on the left, and then equals 13 on the right. Then you have to add 5 to both sides to bring the 5 over. So we now have 2x equals 18. And then divide by 2, x would equal 9. So here, this is your normal type of equation. This has only one solution, and this would be considered a conditional equation. One more example. Here we have 4x minus 7 equals 4 times x minus 1 minus 3. So we want to simplify the right side first. We get 4x minus 4, and then minus 3. And then negative 4 minus 3 would be negative 7. So we've simplified the right side. We can bring the 4x to the left side by subtracting 4x. And now we have negative 7 equals negative 7. So here we have a true statement, And what this means is that we have infinite number of solutions. So infinite number of solutions, and this would be called an identity. All right, so these are the three different scenarios you could come across when solving a linear equation. Next, we're going to switch gears a little bit and talk about absolute value equations. So an absolute value, remember, means the distance from 0. So if you had the absolute value of 4, that equals 4. Absolute value of negative 4 is the distance from 0 of negative 4, and that would still be a positive 4. So distance will always equal a positive number. So in this part of the lesson, we're going to solve equations where the variable is inside of the absolute value symbol. So our equation might look something like this. Absolute value of x equals, and maybe equals to 9. So if that's the case, the numbers we can plug in for x could be positive 9, or it could be negative 9. We have two different answers for this. All right, because if you plug it in, both of those would make a true statement. So in general, we can say that an absolute value equation says that for any variable expression e and any non-negative real number k, the absolute value of e would equal k if and only if e equals positive k or e equals negative k. So that's math notation for what we just explained. So if you have an absolute value equation, we have to set it up so we have two different solutions. We have the e equals positive k or e equals negative k. So let's take a look at a few examples. Here we have the absolute value of x equals positive 23. All right, so for this one, we just realized that x could be positive 23 or x could equal negative 23. Either of those numbers, when you plug it back in for x, will give us a true statement. So that is the most basic type of absolute value equation. Now we're going to increase difficulty a little bit, and now we're going to throw in some other numbers with the x. All right, so here we have the absolute value of 3x plus 4 equals 22. So again, when you're solving an absolute value equation, we take whatever's inside the absolute value and set it equal to a positive and a negative number. So 3x plus 4 could equal a positive 22, or it could equal a negative 22. So when you solve this, we would have to work in reverse order of operations. So we can begin this first equation by subtracting 4. We have 3x equals 18, and then divide both sides by 3, so x would equal 6. Now the second answer, again, we'd have to subtract 4 from both sides. Now we have 3x equals negative 26, and then divide both sides by 3, so x equals negative 26 over 3. So we have two different solutions. X could equal positive 6, or x could equal negative 26 over 3. Let's take a look at one more example. Here we have now increase in difficulty again, and we have negative 2 times the absolute value of 3x plus 4 plus 6 equals 22. All right, when you're doing absolute values, okay, make sure that step 1, we isolate the absolute value. All right, that's step 1. Meaning we must get rid of this negative 2 and this plus 6. So your isolating process is just like with an equation, regular equation, where you have to work in reverse order of operations. So you begin with the addition, and we do that by subtracting 6. So now we have negative 2 times the absolute value of 3x plus 4 equals 16. And then you have to divide by negative 2, because we have negative 2 times this absolute value. So to get rid of that, we would have to divide. So divide both sides by negative 2. We now have the absolute value of 3x plus 4 equals negative 8. All right, now from here, now it's looking like what we had in the previous example. So once we've isolated, then we set up our two cases. So you set up your two different equations, and then once you have your two different equations, then you can solve each of those. So that's your three main steps when solving any absolute value equation. So here we've isolated the absolute value. Next thing would be setting up our two cases. But notice that we have an absolute value equaling a negative number. It's equal to -8. Now remember, absolute value means distance, right? So if it's distance, there's no such thing as a negative distance. So what we have stated here is that some distance, some absolute value, equals a negative number. Well, that doesn't make sense, right? Because distance cannot be negative. So when you see that, this means that there is no solution, because absolute values cannot have a negative number. It cannot equal a negative number. All right, now to finish off this lesson, let's take a look at some applications of linear equations. All right, so we're kind of switching back to just in general the equation and solving process. All right, and here we have just one example. Again, we can use these for any types of application. This is just one that we're choosing to talk about. And here it says Colleen is starting a garden. She has a sunflower plant that is only 6 inches tall, but it is growing at a constant rate of 3/4 of an inch every day. This can be modeled by the equation h equals 0.75d plus 6, where d is number of days from now, and h is the height of the sunflower. And the question is, how many days will it take for the sunflower to be 5 feet tall? All right, so what we can do here to solve this equation, to figure out the answer to this problem, is we plug in the number 5, plug that in place of h, because h is height. So 5 goes in for h, because that is the height that we're looking for. And I guess just be careful that we actually convert to the proper units, because h is height of the sunflower, but it should be in inches. All right, because we're dealing with inches. The 6 here in the equation is referring to 6 inches. So your word problem probably should have clarified, but be careful or be wary of that if needed, you might need to convert. So we do want h in inches. So 5 feet would be 5 times 12, or 60 inches. So we're actually going to plug in a 60 in for h. So what we have is 60 equals 0.75d plus 6. So now when you solve this, we're trying to solve for d to figure out the number of days in which the sunflower will be 5 feet tall. So when you solve, you work in reverse order of operations. We have a plus 6 and 0.75 being multiplied with the d. So working in reverse, we take care of addition first. So we do the opposite of addition, which is subtraction. So we subtract 6 from both sides. That now gives us 54 on the left side, and then 0.75d on the right. And then from here, we can divide both sides by the 0.75. So you can use a calculator if you want, or do this by hand. And the simplest way is realize that 0.75 is 3/4. So you're dividing by 3/4, which is multiplying by the reciprocal, which is 4/3. And then 54 divided by 3, that would give you 1 on the bottom and 18 on the top. Then 18 times 4 would be 72. So when you solve this, d would equal 72, meaning that it will take 72 days for the sunflower to be 5 feet tall. So in this lesson, we have learned how to solve both linear and absolute value equations, and also we learned how to apply that knowledge. And that concludes our lesson for today. We will see you next time.